you all so much. Really glad to be here. In the space program, you have to build hardware that goes into space and it operates in vacuum and ultraviolet light and radiation. And so they have a name for that kind of hardware. They call it space hardened. And we used to joke around that to be an employee in the space program, you have to become space hardened because you have to work all these crazy hours. So honestly, getting here, it was just kind of the norm for a space worker. You hurry up and wait and jump through all the hoops. But I'm super excited to be here today. The world of space exploration and space development is literally growing exponentially right now. We're going to be seeing so many amazing things happening. I keep telling people 2024 is the best year of space ever, and we've only just started 2024. But there are some challenges that we have to face as a society. As we start to expand the reach of civilization beyond Earth into space, we need to figure out the norms. How do we function as a society in this new environment? And so I want to talk a little bit about one of these challenges, the tragedy of the commons in space, the navigating the growing problem of orbital debris. Now this is a graphic made by NASA. Every dot is a piece of space junk, and this is a literal map of the space junk currently orbiting the Earth. Every little thing you see here is a piece of trash in space. Some of them are derelict spacecraft or boosters that were spent and just discarded, or things that exploded and blew out thousands of pieces. And there's literally millions and millions of pieces of trash orbiting the Earth. You can see that there's a band further out, which is the geosynchronous orbit, and then down here we've got this really dense cloud at low Earth orbit, and all the stuff in between is medium orbit. The medium orbit things, that's where the global positioning spacecraft are. And so all this junk floating around threatens to damage spacecraft, and it can ruin spacecraft, which causes the cost of these services to go up. So the cost of global positioning and the cost of data, communications, and it also threatens that we may not be able to even do space missions in the future, as I'll tell you, unless we can get control over this. Now, where does all this debris come from? Well, some of it, quite a lot of it, come from 4 anti-satellite tests. The United States in 1985 smashed a rocket into a satellite, but it was in low orbit, and so the debris cleared out and deorbited within 10 or 15 years. But then Russia tried to several times, but it's generally believed they were not successful. But after that, there was a moratorium. Then China broke this unwritten moratorium in 2007, and they blew up a satellite that was so high that there's almost no orbital drag. And so the debris is going to be in space for decades to centuries. And that's in a region that we have a lot of really sensitive satellites. And then India in 2019, and then Russia again in 2021 just exploded a satellite on purpose and created a huge cloud, millions of pieces of debris. But even a very significant cause of this debris, something that we just didn't know we were doing. We would launch a rocket, push a satellite with an upper stage. When the upper stage was done, you would just discard it, but there would be leftover fuel in it, and the sun heating it would eventually make it explode. And after a while, we realized, wow, our rockets are all exploding and creating all this debris. So we just simply empty out all the fuel before you discard a booster in space. But besides these big events, there's just ordinary space operations. We did not design for sustainability in space. They thought that space was this infinite commons where you just throw your junk in it and it doesn't matter. And so every time they would release a satellite from a rocket, they would use these little explosive bolts, which would blow out debris, or they would use these spring systems that would pop open and the springs would fly off into space. Also, spacecraft over time just degrade in the space environment, and they shed particles. And then the worst problem is spacecraft collisions. Now, there was a movie some years ago called Gravity. I think it was Sandra Bullock, is that right?
Yeah.
I'm seeing nodding. So Sandra Bullock was a movie about a real concern we have called the Kessler syndrome. There was a NASA engineer named Kessler in the 1970s who said, just like in nuclear reactions, if you have critical mass, then it goes into a chain reaction and becomes a nuclear explosion. Well, in the same way, if you have enough stuff orbiting the Earth, if you exceed critical mass or critical density, then you have this runaway chain reaction where one spacecraft crashes into another, which creates a lot more debris, which crashes into another, and then it just goes on and creates this runaway explosion of debris in space, and then could make space unusable. I mean, if this ever happened, if we had so much debris in space, the worst case would be we couldn't even launch into space anymore. And so people in my field really worry about that. How much junk is up there right now? Well, there's millions of objects smaller than a centimeter. One time the space shuttle came back from space, and there was a little crater the size of a dime in one of the windows, and they sampled it to find out what caused that crater. It turned out it was a flake of paint from a Russian rocket. A single flake of paint going 17,000 miles per hour can create a dime-sized crater. So things that are a centimeter in size can be significant. There's over 670,000 between a centimeter and 10 centimeter. And like a centimeter-sized object hitting you at these velocities is the equivalent of a hand grenade explosion. There's 29,000 objects larger than 10 centimeters, and we have about 200 threats to satellites every single day. In fact, ironically, on the way here, I was reading Twitter at the Logan Airport in Boston, and it turns out today we had the closest approach almost to collision ever. There have been a couple of real collisions, but there was a very close approach. Two spacecraft passed within 20 meters of each other. And it was a Russian and an American spacecraft, a derelict Russian one and an active American spacecraft. We have about 200 close calls per day. Some of this stuff crashes on the Earth. We have spacecraft, like about a week ago, a European spacecraft re-entered and crashed over the ocean. Rarely does it land on the land, but it occasionally does. Mostly when things fall on the land, it was from rockets. Or upper stages of rockets. So here's in Myanmar, this was a Chinese rocket. This was an American rocket piece that fell in Saudi Arabia. I forget where this one was. And then this is in China. There's actually a launch site in China that launches over inhabited villages and routinely drops boosters on the villages. So this was from a Chinese news service. There's a booster crashing near a village, and this actually happens routinely. Now in the US, we don't allow people to launch over land. They have to launch over water, or they have to, at least over uninhabited areas. But there's another example of a launch creating debris in a different way. The Starship, which launched from Boca Chica, Texas, just less than a year ago, it launched, and there's the rocket, a 100-meter tall rocket climbing up from the launch pad, and all of a sudden we started seeing these splashes in the ocean, shown by the red circle. These splashes were as high as a 6-story house. Big, giant splashes. And we saw cars nearby get hit by boulders of rock. In fact, you can see it. Watch the car on the left, okay? And you'll see it get hit. So there's the launch, and then something happens, and the plume turns dark gray, which it shouldn't be dark gray, and then the car just got hit. And look at all the junk. Comes the gray stuff, and all these rocks and debris blowing out. Now that's not normal. That's not what normally happens. But I've studied this phenomenon for most of my career at NASA. They actually created a position. I'm retired from NASA, and they gave me a position called physicist of launch pad materials. And so I used to study what happened. I was the only person in the government with that job classification. Kind of a unique job, but I would study how launch pad materials would fail. And this is what the launch pad looked like after the Starship launch. But what really got me interested was this cloud. So this is 10 miles away. They saw this. This was the rocket exhaust. Rocket exhaust is mostly water, so that's a cloud of water made by the rocket. And we were measuring it and calculating the wind speeds because 13 minutes later, the cloud came overhead of these people, and it rained water with sand. There was sand falling from the sky, which never happens. You don't have sand falling from clouds, ever. And so I got people to send me samples, and we investigated it, and we compared to different materials, and we found out it was the sand from down under here. And what happened was the pad cracked, it blew gas through the cracks, it inflated, and it vaporized groundwater, and it built up so much pressure that it was equivalent to a volcanic eruption. It was literally the same velocity ejecta as a volcanic explosion, 90 meters per second, chunks of concrete the size of a car going the length of a football field per second. So that got our attention. And then we realized we need to figure out how to make launch pads not explode. And we actually got funding from NASA to study how to make launch pads not explode in the future on the moon. This is a lunar landing. Now, we have problems with debris on the moon too. Now you can start to see the hazy white glow in the lower left corner. That's the dust blowing as they land. Well, you can't tell from the picture, but that dust is traveling 6 times the speed of a bullet. It's going about 3 or 4 kilometers per second. Okay, so I've spent a lot of time studying that. On Apollo 12, they landed on the rim of a crater, and they sandblasted the old Surveyor 3 spacecraft. The astronaut walked over, cut this camera off, and brought it back to Earth. And this is a piece from that camera that I had in my lab for a few years. This was where a bolt head used to be. And this is the shadow of the bolt head. The shadow is still there, even though the bolt's gone. And it's because they sandblasted the shadow right into the Surveyor from blowing dust from the Apollo. Well, we're worried about that. When we have multiple nations landing on the moon and everybody's blowing ejecta and blowing junk around, how do we manage it so that we don't damage each other's hardware? This circle here is very faint, but that's the outline of the moon. And if you land right here, this is where the ejecta goes. It goes literally all around the entire moon because there's no atmosphere to slow it down. And then this is a picture, there's the moon, a little tiny circle, and this is the orbit of NASA's Lunar Gateway that we're building. And this is what the ejecta does on that length scale. It actually goes higher than the Lunar Orbital Gateway, and so the gateway is going to be flying through the debris. We're trying to find out, after multiple landings on the moon, are we going to start building up this junk in orbit? Will it build up and accumulate? And we don't know yet. But we did work with the United Nations. Space companies were asking me, how can we land on the moon without damaging the heritage sites on the moon? And I asked NASA, and they said, you're not allowed to work on that because we don't want to go to the UN. We don't know what the UN will say. They might give us an answer we don't want to hear. And so one day I had some friends from NASA headquarters helping me on a reduced gravity flight. And at a taco stand over lunch, I said, why don't we, instead of making rules, why don't we make voluntary guidelines, because it's better than nothing. And so we ended up developing this document of voluntary guidelines to minimize the amount of blast damage, the amount of orbital debris you create on the moon. And then eventually Congress adopted it into law, and so now the UN is talking about it. So we got it in through the back door. But what about all this debris that's already up there, all the debris around Earth orbit? We don't know a good way to clear it out. We have a lot of ideas, like spacecraft that can go up and grab some of these spent stages and bring them back down, or nets to capture them. These are actually technologies that different groups are working on. Another one that I really like is shooting lasers at the debris. Now, this is very overly dramatized. They made it look like a big explosion. What you really do is you just shoot a laser and you cause a little bit of the material to vaporize. And that vaporizing material creates a thrust, and it'll slowly push the debris down so it deorbits. So we're working on these different technologies, but we need to get more of a constituency. We need the public to be more involved and wanting us to spend money on this. Now, I included Hawking here. This is a gratuitous mention of my organization that I work for. Hawking said space is our future, and he wanted the public to get excited about space. And so he set up the Stephen Hawking Center at the University of Central Florida. And one of the things we want to do is we want to get the public more involved in space so that the public is invested in it. And so these types of issues like orbital debris, how do we create social standards as we move civilization into space? We want to start addressing those issues, and we want to democratize space. Okay, so I don't know how much I went over. Do we have time?
You're perfect. No,
Okay.
we have time for maybe one or two questions. First guy that raised his hand, he's going to shout it out, and I'll repeat it.
Pray tell, what is microgravity?
Good. Okay, what is microgravity, Phil?
Okay, great question. So we probably should just call it zero gravity. It'd be a lot easier to just call it zero gravity. But when you're in orbit around the Earth, you're still in the Earth's gravity, but you're free falling. And you're falling as fast as the gravity is pulling you down, so it feels like there's no gravity. But if you're in a big spaceship, the whole spaceship is falling, and it's the center of the spaceship that's falling the exact right amount. If you're on the other sides of the spaceship, you actually feel a little tiny bit of gravity because it's only the center of the spaceship that falls the right amount. So that little bit of gravity that you feel everywhere else we call microgravity. So it's just people being perfectionistic instead of just calling it zero gravity.
Okay. Yes.
I'm just a bit curious if the debris from landing on the moon might affect satellites in orbit of Earth, because I noticed that some of the debris went to escape velocity.
We don't know. That's a great question. We know that the rocket exhaust blows dust up to the speed of the gas, which is 3.5 kilometers per second. Escape velocity on the moon is 2.4 kilometers per second. So you do blow dust completely off the moon if you have a big enough rocket landing on the moon. But we don't, there's already dust in space, and it already abrades your spacecraft, and that's just part of the natural environment of space. What we're worried about is if we create an artificial environment which is worse than the natural environment, so it becomes more abrasive and more degrading. And we don't know yet, will the solar wind clear out that dust faster than we put it in? Or will the rate of landing on the moon create the dust faster than nature clears it out? And we had students working on that, but we haven't got to an answer yet because it's a really hard problem. So I can't tell you yet. Okay.
Okay. Well, Phil, fantastic presentation.